Hello and welcome back. Sean here, Mountains Garage, on an early overcast Saturday morning, but I think the sun's gonna come out. Pull up a chair and I'll tell you my slightly frustrating week attempting to move forward on assembly of my former ILMOR Engineering 396 LS motor. Now it's a 440 cubic inch, gonna be twin turbo in my race 55 Chevy. I'm piecing it together, low buck if you will, exotic parts that I'm trying to low buck the whole project, and still have a reliable engine with quality pieces. You just got to shop and get lucky every now and then. So in the last video, the heads were assembled, the short block was already assembled. The only thing holding me up was I wanted to measure the combustion chamber CCs so I could go online to any of the compression ratio calculators and reassure myself that I didn't have too much compression. I have too much compression, but that is what it is. It'll be fine. I'm trying to keep it under 12 to 1. Anywhere in the low 11s is better with the combination of parts that I have. These heads are advertised at 66 cc's, but they've clearly been improved and polished, which usually takes material away. So I was hoping for somewhere between 66 and 70 cc's. I used to have a similar measuring kit. This is from Summit. I think it was $27 or $8. Subject to change. You can go online if you need one to check it yourself, but I had to spend more on Summit racing to get free shipping, so I threw this in the cart. I was going to borrow one. I had one that's broken. This piece was broken, and this is something I had made. But this is the way the kit comes. This is what you get. You take a little, I use Vaseline, go around the combustion chamber, put it so the hole is accessible. You have to tilt the head so the hole's kind of at the highest point, because as you fill with a tiny funnel, you want all the air to come out. You want to completely fill the chamber, because a milliliter of fluid is not very much. It's a dribble. So you can't spill any, you can't have any leak if you're going to be accurate. I actually did it 3 times, and I come up with 68 cc's, so my hunch is correct. Again, it got polished a little bit. That's good. So my total calculated compression ratio, you have to measure how far the piston is down from the deck of the block, the bore and stroke, number of cylinders. Now in an engine, just changing the bore and stroke, you gain compression if nothing else changes. There's no way around it. Just because you have more displacement, you more squeeze, it's going to happen. So I calculate 11.8, like I said, I think I said. Anyway, it is what it is. It's going to run at that. So that we were past that. It was now time to attempt to assemble the heads onto the block. I have the ARP super expensive stud kit. If you have a dot cast iron block, the head studs for aluminum block are different, and it's specific only to this block. So Dot sells their rebranded ARP studs. The picture they use is the same, and I was on the phone with the ARP tech guy, and he confirmed that yes, the Dot studs at $800 are the same ones that you can pick up. I stole these for a mere $560. They list for $700 and change. There are no other choices. With this, if you're going to put heads on this block, this is what you get. If you know of anything else, I haven't found it. If you know of anything else, be sure to let me know. I love reading all the responses when you get them. So, again, this head stud is made exactly for this block. But somewhere along the lines, these are 2 premium companies, Dot Blocks, or Dot Machinery, and ARP, the most famous, top-of-the-line fastener, high-performance fastener company there is. Well, somewhere along the line, this is considered a 23-bolt head compared to a stock LS engine, which has head gasket problems, under boost at least. They've added 4 on the outside external, 4 internal. And these are studs, and there's a nut and a washer down inside the lifter valley. If you saw the second picture when you were turning the video on, we're going to get to that problem, but one problem at a time. I knew through mock-up that these studs weren't long enough. They come with a washer and a 12-point flange nut, and with the washer and flange nut on the stud, it's only halfway into the nut. So a little research, talked to both ARP and Dart, because they just point the finger at each other. At some point, either the block got tapped deeper than expected, or the studs that they chose to provide in the kit are too short. Either way, it's not a good situation. On the phone with the ARP tech guy, he knew exactly what I was talking about, and he said you can just either back the stud out and put the washer and nut on, or just leave the washer off. I told him my fix, and I had read it online, I cannot take credit for it, is I took a 1/4-inch check ball from the valve body of a Turbo 400, and I dropped it in the hole in the block, and then threaded the stud down. And the stud actually has a concave portion. The check ball fits nice in the hole. It centers up, and it prevents the stud from going, 250 thousandths deeper. And now my spacing is correct. I'm still threaded in the block, 5/8 of an inch probably, so it's not a strength concern, and they all lock down the same. So he said, wow, you mind if I tell other people that if they call with that question? Sure, no problem. Again, I can't take credit because I read it online somewhere. Somebody said just drop a check ball into the block, the hole in the block. The holes are blind. Now you got to remember the check ball's in there, and once you've got the head on the block and you drop this in the hole, you got to take the head back off to get it out unless you have a tiny magnet. It's not impossible to get it out. I guess I could roll it over on, maybe they'll dump out on the floor, but it's a loose part you got to keep an eye on when you take it apart. So I had solved that. So I knew that in mock-up. I thought I had everything covered. So I got my head gaskets out. This is a GM head gasket. Some people are going to want the part number. They're right and left. They come in one package for 200 and change. Part number is 19170419. There are 4 200 bore, because again my block is 4 185, and there's a right and a left, and they're all metal. They're MLS, but I expected there to be something maybe rubbery and gooey on either side of it. It's not, it's metal. And they fit very tight over the cylinder head dowels in the block. I actually had to gently get a socket and tap them down over. I didn't damage the gasket, but I would have preferred to not have to do that. But either way, I'm moving forward. This is engine assembly, or any assembly is all about how much force you can apply to something without wrecking it. I've said that a few times. Applied force technology. So I carefully got the gasket over the dowels. I guess I could have filed it out, but I really shouldn't have to or don't want to. But that's here and there. I got the gasket on the block. My preferred method is to set the head on with maybe one stud just to guide it, and then put the studs in afterwards, because putting the head down over the studs the first time, if it's been on the block and torqued down and you take it off, they're probably all in alignment, if you will, but they tend to rub aluminum off onto the threads just getting the head over them, all of them. So it's just as easy to put them in afterwards. Each stud has an Allen socket in the end, if you will. So it's really not a problem to put them in afterwards. So I carefully put the stock ones in. I put the upper ones in. I had already put these in the head and ran them down. These go into the lifter valley. And that is where the next problem came from. I put all my studs and nuts on the outside. I haven't torqued anything yet. I knew just putting the washer and the 12-point nut on this stud inside the lifter valley, they give you a window to work in, but it's not, you can't get, you might get, I can get 2 fingers in like this. I've rolled the engine over some. In the car, this would be very difficult. To even get the washer and the nut onto the stud, I take my angled pick, I put the washer over it, the direction I want it to go, and I reach down into the engine and put this in the Allen portion and wiggle it around, and you can get it to drop on. Do the same thing with the nut. Get it wiggled into position in this. Well, I could not achieve either one of these. I couldn't get the washer onto the stud because it rubs the block right there. First clue, I had a problem. Okay, I thought about it for a while. I said, I'll just grind a flat in the washer so it'll clear the block. And I had the washer on the stud. Next, I cannot start the nut because the flange of the nut rubs on the block. And between the cylinder and where this is, I mean, the block's a ½ inch thick, so there's no reason why this shouldn't be machined for plenty of clearance. But there was no machine work on my block. So I took the nuts and I reduced the flange a little bit so I could get them on there. And I have two, in the picture if you look, there's 2 washers and 2 nuts on the studs in my lifter valley. Next problem is, take any wrench in the free world, regardless of how thin it is, and you cannot get it to clear the block. And I messed with it for a little while, and I thought, okay, maybe if I had a 6-point nut, I could just grab it and use the open end, and I would be able to tighten it. You got to get to 28 foot-pounds. So it's a situation where it's going to take quite a bit of stress on the tightening device. What do regular people do? So a friend of mine, Tom Vigu, 3V Performance, North Carolina. I've known him for 40 years probably. We don't talk often, but I sent him a message yesterday afternoon. I said, what do you do? He said, well, I've never studied the ILMOR block because he used to work for different NASCAR teams. He's a Spintron master. The guy knows some stuff. I try not to bother any of my friends that have all this knowledge, but occasionally you get to the point of frustration where you just want the answer. So he sent me a picture of his dot blocks because he has some in stock, and his are machined exactly where I have a clearance problem. Clue number 1, my block's not machined. So this was later in the day. I had already talked to ARP first because I have a second stud set and I'm missing these 4. The second ILMOR block that I bought came with a stud kit, and I was inventorying it when I was trying to figure out what would have been used, and these 4 were missing. Well, 8 total, 8 studs, 8 washers, 8 nuts. So while I had the ARP tech guy on the phone, I bought another 8 studs to go with my other kit so it would be complete. It turned out to be a waste of money. That's okay. They'll be here next week, and I'll put them in the box, and I might use them someday. The ARP tech guy says, not our problem. After we talked about these studs, he says, you should probably talk to Dart. All right, so it was a Friday afternoon. I actually was no problem getting through to the Dart tech guy. And he wasn't sure what machining was done on the ILMOR block, but he said, all I need to tighten these up is a 3/8 12-point crow's foot wrench. Now I have a lot of tools, and I don't mind buying more tools. I've yet to find a 3/8 12-point crow's foot wrench, but I only searched for a couple hours. And that's what I was doing last night, and then I got distracted by other YouTube videos, and right around midnight, it occurred to me. Boof, epiphany. Is that what you call it? So I had to come out and confirm my suspicions. So all the evidence added up. 1, my block isn't machined where these studs go. But I bought a second block. The second block I bought is a later ILMOR engineering unit. Between the lifters, on the camshaft side of the block, down here, there's a stud, and it's set up for dog bone style lifters. And I remember I dragged the block home, I just threw the heads and intake on it and made a dummy engine out of it and pretty much put it in the 55. Didn't spend a lot of time studying it. I looked at it when I bought it in the guy's basement. completely missed the fact that the ears on the block that these would go down through are completely machined off now on the second block. ILMOR does not use these studs. They never used it on this block, and they cut them right off my other one. Now, first I was disappointed and somewhat elated at the same time, because the whole time I'm trying to get this nut and washer for the last 2 days, and I ordered these 6-point ones, and I ordered these in a lock nut because I am afraid of what happens. You got aluminum head, cast iron block, expansion and contraction. If these loosen up, this nut's going to fall into my lifter valley on the camshaft, fall into the timing chain. Now, I ran these, I had a dot big M block and dot cylinder heads on my big block in my last race car. And I had the Valley stud kit. It was larger on a big block Chevy at 7/16 on one end, 3/8 on the other. This is 5/16 and 10 millimeter. I mean, compared to the rest of the head bolts, it's 4 tiny little studs. I would prefer to have them all there. However, I'm not going to miss the nut potentially falling off into my engine. Because in this area, if you study, the problem with an LS cylinder head is they only had 10 here, right? 2, 4, 6, 8, 10, and these small ones here. So this area, these are duplicates between an area that doesn't have a problem. So I can see why they left them off. I don't know if the GM LSX block even runs them. I'll have to check my buddies to see if he has that, but, well, probably because the gasket has holes for them. I'm talking these holes right here. 1, 2, 3, 4. Long story short, I'm not doing a good job at finishing up that I have to pull this head back off. I haven't torqued anything, remove the 4 studs and put the heads on. I could strip this block, machine out for these studs, and just worry that, whether they come loose or not, because they probably won't. I don't think I'm going to miss them. So I'm not going to do that. I'm not taking this engine apart. And when I build the second block, it's not even an option because the ears are gone off the block. That's how serious ILMOR was about not needing them. Of course, they weren't boosted or anything. But again, the problem with an LS cylinder head, when you blow out a gasket, it goes this way. I have extra bolt holes there. The dot block has 7/16 studs, which is only slightly bigger than the M10 GM block factory LS bolts, but I could go to 1/2 inch here. It's an option too. So should I have cylinder head problems, gasket problems, and I've already stated my plan is to run 15 pounds of boost or less, which a stock LS head will handle that in block. So I'm hoping not to push it. Everybody says that. So I'm still, again, I was out here half the night, thought about it ever since, putting this out in my video world to cover the fact when I review it years later of how I came to this conclusion. So that is what I'm going to do. And of course, with block number 1, we'll call this one, should this ever bother, I have 2 sets of studs now. I can, with the engine torn completely apart, machine the block enough so I'd have room for my nuts and washers, and I could put these back on this engine. So, but again, I'm going to get used to not having them, and hopefully it'd never be an issue because the second block can't have them. So that's that. Enjoy your Saturday. If there's anybody still watching, next time you see the engine, I'll have it both heads on. And I need to measure for push rods. I need to get that done this weekend because the way these are limited travel lifters, I did not want to measure until the cylinder head was tight, the gasket's compressed. I wanted to be as accurate as possible. My window of, my margin of error is smaller on this engine than other type of engines. So I want to make sure my lifter preload is spot on, and that's done by the length of the push rod. So I'll get the cylinder heads on and get that done, and then I can put the valley cover on. And I have the actual ILMOR steam kit. These heads have, looks like a dash 3 and fitting where the typical bolt-on steam kit on a stock head is. So that's going to be nice. I have it. That's awesome. So thanks for watching. If you're still watching, this one's a little bit dry, but what are you going to do? Have a great day. Talk to you soon.